Hello, welcome back to another video of Math of the Day presented by Jude Didelot. It is currently May 22nd, 2025. Today we will be learning about factorials. To start off, I have a little demonstration. Here I have a battery, a Lego figure, and a USB mouse receiver. My question is, how many different ways can these three objects be rearranged? When I mention rearrange, I mean like this, where you switch the order of two objects. The current arrangement counts as one arrangement, but I want you to find the rest. Feel free to pause and grab three different objects and do this for yourself. I will give you a few moments. Hopefully you tried and figured it out, but now let's do it together. As I said before, this set with the battery, the Lego figure, and USB count as one arrangement. But this could also be another arrangement. So that's 2, this one's 3, this one's 4, this one's 5, and this one's 6. We got a total of 6 arrangements because this is the maximum amount of arrangements that we can have. Now if we were to do this with 4 objects, we would have 24 arrangements. And if we were to do this with 5 objects, we would have 120 arrangements. That's a lot of arrangements. Did you see any patterns? Well, if you didn't, that's okay. Let me explain. So every time, here, let me grab this paper real quick. Every time you add a new object, the amount of arrangements for the new object is the existing amount of arrangements for your original set. So we have 3 objects. So the existing number of arrangements would be 6, just like how we figured out a little bit ago, times the new number of objects. So if we were to add another object, it would be 4 objects. So that'd be 6 times 4, which is 24. So if we had 4 different objects, this means that the total number of arrangements would be 24 arrangements. We can also do this backwards. Let me slide this piece of paper down. So when you're subtracting an object, the amount of arrangements for the one less amount of objects is equal to your existing number of arrangements, which is 6 arrangements for 3 objects, divided by the existing number of objects. So this would be 6 divided by 3, which is 2. So this means if we were to take an object out, the arrangements for 2 objects would be 2 arrangements because it's 6 divided by 3. And this makes sense because you can either have it like this, where you have the Lego figure and the battery, or you can switch it around and you have the battery and the Lego figure. And now we can also figure out how many arrangements one object has. So we would take the existing number of arrangements for 2 objects, which is 2, divided by the existing number of objects, which is 2 objects. So 2 divided by 2 is 1. And this obviously makes sense because the amount of arrangements for one object is just one arrangement. So these kind of, the amount of arrangements that we can have for a number of objects is known as a factorial. So this basically means every time you increase one object, so if we add another object here, the amount of arrangements, the amount of arrangements is just 1 times 2, which is 2. And now if we were to add another object, it would be 1 times 2 times 3, which would be 6. So we'd have 6 arrangements for 3 objects. If we would add another object, it would be 1 times 2 times 3 times 4, which would be 24 arrangements for 4 objects, and so on. If you had 5, it would be 1 times 2 times 3 times 4 times 5. So yeah, as I said, those kind of ways of arrangements of objects are known as factorials. And when you just find the factorial of a number, so my demonstration was just with objects, but factorials are used all over math. It's just that number, so let's just say we have 3 objects, times all the numbers before it until you get to 1. So 3 times 2 times 1. This is known as 3 factorial, which 3 times 2 is 6, times 1 is 6. And factorials are often defined as having an exclamation point after that number. So if we wanted to find 3 factorial, the notation would be adding a little exclamation point after, which this basically means multiply all the numbers before until 1, and these have to all be whole numbers. So this would be equal to 3 times 2 times 1, which is equal to 6. We could also do this for 4 factorial, which is equal to 4 times 3 times 2 times 1, which is 24, because 4 times 3 is 12, times 2 is 24, times 1 is 24. And that's how I also got 120 arrangements for 5, because 5 factorial is just equal to 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So today we have just learned what factorials are with a fun demonstration. I hope you learned something new today. Thank you for tuning into Math of the Day, and goodbye.